Okay, so get this, right? You can whisper just a few words to a machine.
Mm-hmm.
It can compose music,
Yeah.
write poems,
Wow.
even create art, all just for you.
It's crazy.
We're talking about AI that seems like it's straight out of science fiction,
Yeah.
and the heart of it all is something called a transformer. It's what's powering all those like
Yeah.
mind-blowing models like ChatGPT that you hear so much about.
Right.
Now, we've got a stack of your sources about transformers, including the original research paper that quite literally like changed the game.
Mm-hmm.
Plus, we've got those awesome visuals from 3 Blue 1 Brown to help make sense of it all.
Yeah. They're great.
So, ready to unlock the secrets of how these things actually work?
Absolutely. Let's break it down.
Perfect, because today's deep dive is all about demystifying these transformers.
You know how these models, they seem to like understand language with almost a human-like grasp?
Yeah, it's kind of eerie sometimes. Like, how do they do that?
Well, before Transformers, AI was stumbling around like it had a dictionary, but no grammar book.
Okay.
We're talking about older models like RNNs,
Mm-hmm.
recurrent neural networks, and CNNs, convolutional neural networks. They were like the go-to tools for tasks like translation,
Right.
but they had this major flaw.
Okay.
These earlier models really struggled to understand how words related to each other over longer stretches of text.
So, like, they couldn't connect the subject of a sentence with the verb if they were, like, pages apart.
Exactly. Imagine trying to understand a story where the most important details are just, like, scattered randomly throughout.
Yeah.
It would be nearly impossible to follow the plot, right?
Right.
That's what it was like for these older models.
Wow.
Yeah.
No wonder those early chatbots could be so frustrating to talk to. It's like they had short-term memory loss or something.
Yes, they couldn't remember enough context to hold a coherent conversation.
Okay.
The meaning would get lost if the crucial words were too far apart in the input.
Yeah.
But that's where the 2017 paper, Attention is All You Need, like swoops in to save the day.
Okay.
They introduced this revolutionary concept of attention, and it's been a complete game changer for AI.
Okay, so attention. Is it literally like focusing our attention when we read, like tuning out distractions and zeroing in on the important stuff?
You got it. Think about how you read a news article. Okay.
You don't give equal weight to every single word, do you?
No.
You skim for key phrases.
Right.
You focus on the headline. You might even skip over the entire introduction.
Yeah.
Because you want to get to the juicy bits.
Okay, that makes sense. We're constantly filtering and prioritizing information as we go.
Exactly. And that's what self-attention does in Transformers.
Okay.
Instead of just processing words in a linear sequence, attention allows the model to focus on the most relevant parts of the input.
Okay.
Each word gets to look at all the other words in the sentence and figure out which ones are the most important for understanding the overall meaning.
So, if we're reading a sentence about a cat chasing a mouse, the word cat is going to be paying close attention to chasing and mouse, right? Precisely. It's like the model is highlighting the key players and actions in the sentence.
Okay.
And the really cool part is that the paper actually shows how different attention heads, these like parallel processors within the model, learn to track these relationships.
Got it.
It's almost like having a team of expert readers, each with their own specialty, working together to understand the text.
Wait, different attention heads with different specialties. Yeah, I need an example.
Sure. One head might be all about nailing that subject-verb agreement across a sentence, making sure everything agrees grammatically.
Important for avoiding those embarrassing grammar mistakes.
Absolutely.
Yeah.
Meanwhile, another head might focus on how adjectives modify nouns, like figuring out which qualities describe which objects.
So one head is the grammar police.
Yes.
And the other is like an interior decorator, adding those descriptive details.
Exactly. And because these attention heads can focus on relationships between words no matter how far apart they are in a sentence, they solve that pesky long-range dependency problem that plagued those earlier models. It's like they finally have the tools to understand the full context of what they're reading.
Okay, I'm starting to see why this attention thing was such a big deal. It's like they gave these models a superpower upgrade.
Yeah.
But how does this all actually work in practice?
Well, let's step inside the transformer itself and take a closer look.
Okay.
Imagine it like a well-organized factory production line.
Perfect, because I have a feeling this is where it can get a little complicated, and I want to make sure we don't lose anyone in the technical weeds. A factory production line. Okay, I'm intrigued. Walk me through it.
So first things first, we need to get those words into a format that the transformer can actually work with.
Right, because AI can't exactly read and understand text like we do with our eyes.
Exactly. So the first stop on our production line is the embedding station.
Okay.
Here, each word gets transformed into a vector.
A vector.
Think of it like this. Imagine you have a dictionary.
Okay.
But instead of just giving you the definition of a word, it also tells you all the other words that are related to it in different ways.
So for cat, you'd have feline, meow, pause, all those related concepts.
Exactly. And you could represent all those relationships as a list of numbers.
Okay.
Showing how close or far apart each concept is from cat.
Right.
That's essentially what a vector does.
Okay.
It captures the meaning of a word by representing it as a point in a multidimensional space where similar words cluster together.
Okay, that makes sense. It's like turning words into a kind of code that the transformer can decipher.
Precisely. And with the words transformed into these numerical representations, the transformer then employs its secret weapon, multi-head attention.
Okay.
It's like sending those word vectors down, like multiple conveyor belts, each one representing a different attention head.
Right, those expert readers we talked about earlier.
Exactly.
Each with their own area of expertise.
Yeah. Exactly. Imagine one conveyor belt focusing on how words relate to each other grammatically, like figuring out which noun goes with which verb. Another conveyor belt might analyze the emotional tone of the words, while another looks for connections between different concepts.
So each attention head is analyzing the text from a different perspective.
Yes.
Picking up on different layers of meaning.
Precisely. And because they're working in parallel, they can process all this information much faster than if they were working one at a time.
Okay, so the words have been turned into vectors. They've been analyzed by these attention heads. What happens next?
Well, all those insights from the attention heads need to be combined somehow, right?
Yeah.
That's where the feed-forward network comes in. This is like the assembly line where all the parts come together.
Right.
It takes all those different analyses from the attention heads and integrates them into an even richer, more nuanced understanding of each word and its context.
So it's like taking all those highlighted phrases from our expert readers and finally piecing together the full story.
Exactly. And once the feed-forward network has done its job, we're finally ready for the grand finale, the output. This is where the transformer actually generates the next word in a translation, or the next line of code in a program, or even the next brushstroke in a painting.
Wow.
It takes everything it's learned from the attention process, integrates it with its existing knowledge, and then produces the most likely or relevant output based on the task at hand.
Okay, that makes sense. But there's something that's been bugging me.
Okay.
We've talked about how transformers process information.
Right.
But how do they actually store knowledge? Where are all those facts and figures hiding within these models?
That, my friend, is the million-dollar question that keeps AI researchers up at night.
Yeah.
It's not like traditional computer programs where you have neatly labeled files and folders for every piece of information.
So that's not like a giant digital encyclopedia?
Nope.
Okay.
Transformers store information in a much more distributed, interconnected way. It's not about individual neurons or parameters representing specific facts, but rather about the patterns of activations across the entire network.
Patterns of activations? That sounds pretty abstract.
Let me give you an example.
Okay.
Let's say we're teaching a transformer about Michael Jordan.
Okay.
Now, there's not going to be a single neuron in the model that lights up and says, hey, I know everything about Michael Jordan.
Okay, so it's not like a dictionary where you can just look up Michael Jordan.
Exactly. Instead, information about Michael Jordan is spread out across the entire network.
Okay.
Some neurons might fire when they encounter his name. Others when they see words like basketball or Chicago Bulls.
Right.
And still others when they detect patterns related to his playing style or achievements.
So it's like a giant web of associations where different concepts are linked together based on their relationships to each other.
You got it.
Okay.
And it's the specific pattern of activations across this entire web that represents the concept of Michael Jordan within the model.
Wow.
It's kind of like how our own brains work.
Right.
Where memories and knowledge aren't stored in specific locations, but are distributed across billions of interconnected neurons.
That's incredible. So it's not about finding the Michael Jordan neuron,
right,
but about understanding the unique symphony of neural activity that represents him within the model's mind.
Exactly. And this distributed representation
Right.
is what allows transformers to be so incredibly flexible and powerful.
Okay.
They can learn complex relationships between concepts,
Yeah.
generalize from one domain to another, and even come up with creative solutions to problems they've never seen before.
Okay, this is seriously blowing my mind.
Mm-hmm.
We've gone from basic word vectors
Yeah.
to multi-headed attention
Mm-hmm.
to this mind-boggling concept of distributed representation.
Yeah. It's pretty wild.
But where do we go from here?
Well,
what's it all mean?
That's the question, isn't it? And it's not just about building fancier chatbots or more accurate translation tools.
Right.
This is about the very nature of intelligence itself.
You're saying transformers aren't just a cool technological feat? Like they're actually giving us clues about how intelligence itself works.
It's a possibility, isn't it? Think about it.
Yeah.
These models are learning to communicate, generate creative text formats, even write different kinds of creative content.
Oh, wow.
All by analyzing massive amounts of data and finding patterns.
Right.
It's not biological.
Right.
But the outcomes are eerily similar to how we think humans learn and create.
So we've gone from teaching machines to mimic us to machines potentially unlocking new forms of intelligence. Forms of intelligence we might not even fully grasp yet.
It's a bit of a head trip, isn't it? And the implications are huge.
Right.
What happens when these models can process information exponentially faster than us?
Right.
Connect dots we didn't even know existed.
Yeah. It's exciting.
Yeah.
But a little intimidating too, right?
Yeah.
Like, where do we fit in if machines are out there composing symphonies and writing the next best-selling novels?
That's the million-dollar question, isn't it? But I see it this way.
Okay.
We're not just along for the ride.
Okay.
We're the architects of this technology.
Okay.
We're the ones shaping its development, guiding its applications.
So it's less about being replaced and more about figuring out how to collaborate with this new form of intelligence.
Exactly.
Okay.
Imagine the possibilities.
Yeah.
We could have AI partners helping us solve complex scientific problems,
Right.
generate innovative solutions to climate change, even personalize education in ways we can only dream of right now.
Okay, now I'm getting those chills again, but the good kind this time.
Yeah. It's about harnessing this power responsibly,
Right.
ethically.
Right.
And that's a conversation we need to be having now,
Right.
not later. But the bottom line is, this technology isn't going away.
Right.
It's up to us to make sure it's used for good.
So what you're saying is understanding how transformers work isn't just for, tech wizards anymore. It's for all of us.
Absolutely, because this technology is about to change everything.
Yeah.
And the more we understand it, the better equipped we'll be to navigate the future it's creating.
Wow. Talk about a deep dive. We've gone from the nuts and bolts of attention to the future of intelligence itself. If this has sparked your curiosity, we've got links to all those fascinating sources in the show notes. Go check them out. And until next time, keep those brains buzzing and stay curious.